Hello everyone. I'm going to explain about the examples of E1cb reactions. Okay. In my previous video, I told you about the mechanism and which carbon, which proton does it attack, where is the double bond being formed. Okay. So I'll just tell you in gist. Okay. Before going on to my video, let me tell you a motivational quote: optimism is happiness magnet. If you stay positive, good things and good people will be drawn to you. Okay, so let us think positive to succeed in life. Okay, let us take the example 1. So I told you the leaving group will be in the C alpha position, carbon alpha position. The hydrogen, the base that attacks, will be at the beta carbon. Okay, so see here, this example, we have X as the leaving group. Okay, so that is C alpha position, and we have base getting attached to the hydrogen at the beta position. So what happens? BH is removed. Okay, and there is a shift in the hydrogen bond. Okay, as a result, what will happen? There is a double bond being created, and again that double bond is shifted towards the oxygen. As a result, what happens? You find that it becomes O minus. Okay, in the next step, this is the transition state. In the next step, what happens? There is a shift of electrons. So from the oxygen, there is the electron coming to this bond, so you get double bond O, and this bond gets shifted between C alpha and C beta position, so you get R1 C double bond O, CH, C, R2 and R3. Okay, so guess what will be the product formed here? We have a cyclopentane group with a keto group at one position, and we have methyl group and OH at another carbon atom. Okay, so OH is the leaving group. So this is C alpha position. C beta position is the CH3 and hydrogen is getting attached there. So OCH3 minus, a base gets attached to the hydrogen, which I have shown in the green color. Okay, and there is a shift in the bond. Okay, so what happens? See here clearly it is seen that the product formed is C double bond O cyclopentane group with a keto group at the first position, and you have at the C4 C5 position a double bond. Okay, so let us take another example. You have a benzene ring with the CN getting attached, and another carbon atom to which two cyanides and one hydrogen atom is attached. So this one cyanide which I have shown you is the leaving group. Okay, so that is C alpha position, and this one is C beta position. So what happens? The base is triethyl amide. This group gets abstracts the proton. Okay, and there's a shift in the electron, so you find carbanion to be formed at C alpha beta position. Okay, and then in the next transition state, what happens? This electron gives a double bond between C alpha and C beta position, and cyanide gets removed. So benzene, C, Cn double bond, C, Cn, and Cn is the product formed. Okay, guess what is the product formed here? You have a base NH2 minus, and you have carbon CH2, CH3, C double bond C, CH and Br. So this Br which is attached is C alpha position. Okay, and this proton base attacks the proton. Okay, and there is a shift in formation of carbanion. Okay, and in the next step what happens, the leaving group is removed. As a result you get a triple bond here, okay, between C alpha and C beta position. Okay, let us take another example. See here, you have a benzene ring, fluorobenzene. You have a benzene ring with fluorine as the leaving group. Okay, so this is C alpha position and this carbon is C beta. Okay, so base abstracts the beta proton. Okay, you get carbanion to be formed at C beta position. Okay, and in the next step there is a shift of the electrons. As a result what happens, the fluorine atom is removed, F minus is removed. So you get benzene to be formed. Okay, let us take another example. Here you see CH2OH. So this is alpha carbon. Okay, and next one, CH2 is attached to another carbon which is beta carbon. So you have beta proton there. So OCH3 minus attacks the proton. So carbanion is formed. In the next step you can see this one. Okay, and this carbanion, the electron gets shifted. As a result what happens, you get double bonded CH2 to get attached. So here these examples I am giving you in order to show the double bond is formed between C alpha and C beta position. C alpha is nothing but the leaving group is C alpha group. Okay, and C beta is next to that carbon. It should have a proton present in it. Okay, let us take another example. You have here CH3 C double bond O, CH2 CH2O CH3. So OCH3 is the leaving group. Okay, so that one is C alpha position and this one is C beta position. So what happens, OCH3 attacks the proton. You get carbanion to be formed. There is a shift in the electron. As a result, double bond is obtained and OCH3 is removed. So CH3 C double bond O, CH double bond CH2. Okay, let us take another example. See here, you have the base attacking the hydrogen, this hydrogen atom. Okay, so what happens, there is a break, okay, of bond. So you have two molecules to be formed. One is CH3 C double bond O, CH CH2, and another one is X with a benzene ring and CO double bond O. Okay, so there's another example here. So you find that the base attacks the proton. So the alpha carbon is OCH3. This carbon is alpha carbon and the hydrogen which is attached is beta carbon. Okay, so the base attached the beta proton. Okay, so carbanion is formed at beta carbon. Okay, and there is a shift of the electron, so you get a double bond and OCH3 is the leaving group. Okay, I hope you all understood about this examples of E1cb reactions. Okay, so main thing is the leaving group attached to the carbon is alpha carbon. The next is the beta carbon which should have a acidic proton. Base attacks the acidic proton and a double bond is formed between C alpha and C beta position. So in my next video I will be explaining about the comparison of E1, E2 and E1cb reactions. Okay, I hope this video was useful. Thank you.